11.6. Okay, so let's do this. 2 is equal to x squared plus y squared. Am I in the right book? Yeah. You never know. I just want to make sure. So that looks like the equation of a circle. And what we are supposed to do to it is find the center and the exact radius. So what did we say from the equation of the circle when it's written as such? Is the center of the circle. HK. And what is the radius? R. Okay. So in this case here, what are the H and K values?
X and Y?
0. Because x subtract 0 is x, and x squared is x squared. So this is just 0, 0. The origin is it. What is the radius of this? 2. How much? Square root of 2. Yeah, the exact would be the square root of 2. Did I give you number 6? Was 6 assigned? No. Okay, was 3 assigned?
Yep.
Okay, so the center of the circle for 3 would be 5, -7, yes, because it's written as y plus 7, and that, if you wrote that in subtraction, it'd be y subtract -7. Okay, just wanted to check on that. Hey, do you know where all their papers are? Remember we collected them? You collected them? And you took all the blue tape off of them so that they would stack nicely?
Yeah.
See, they just gotta dig it up. Okay, let's do 9. While we're looking for this stuff. Find the coordinates of all points of the intersection of the circle. Okay, so. Oh, they're in there with the drawing packages. Sweet.
Banged his elbow on something.
Okay. So.
Smart place.
We don't need
Jacob
them
could have
now.
told you.
I'm doing other things right now. Though.
Okay.
Okay,
You're
thanks.
welcome.
So this one here, they have x minus 5 squared. What am I doing? X minus 5. Better start all over again. Y. Y minus 2 squared, and that's 36. Okay. So we need to find where x is equal to 1. So this is going to be on a coordinate plane somehow. What's the center? What is this point here? 5, 2. Okay. So that'd be 5 over and 2 up from the origin. What's the radius? 6. So that means that this edge right here is where relative to the x-axis?
What?
So this edge of the circle here, where is that relative to the x-axis? -1, because here's a radius of 6, this point is 5. If you count back 6, that's at -1. So then the y-axis is something like this. And then the x-axis is located where? Above or below the center? This is 5 over and 2 up. So it's 2 above. So the circle is sort of like this. It goes 2 above, but it goes 4 below, so maybe my line could have been a little bit higher up, but still, it's something of this nature. And what we're doing is we're finding out when x is equal to 1, there's going to be a point on the circle here that gives a y value. And then there's going to be another point up here where x is equal to 1. That gives a second y value. So there's going to be 2 solutions that you're going to find. Yep.
So my trouble with that was that it was never on a perfect, like, intersection of the point.
No, it never will be
So
hardly.
how do you solve for that then?
That's where you have to do things exactly. So if x is equal to 1, we can just go right to the equation. And we would then write that as 1 subtract 4 squared plus y subtract 2 squared.
1 subtract 5 is 5, right?
Oh, 5, thank you, yeah, 1 subtract 5 squared. And that's all equal to 36. Wait a second, Jack. Yeah, that's equal to 36. Are we okay?
How? And so you just leave it as that, or do you solve?
Well, you have to solve it. Can you simplify this? Sure. So you have negative 4 squared. Subtract 16. Y subtract 2 squared is equal to 20. Then what?
Square root.
Square root of both sides. So I'm going to come up here. So y subtract 2 is equal to the square root of 20. Now what? We add 2 to both sides. So this is one solution. Two plus the square root of 20. But see, because we were taking the square root of a variable, that variable could have a positive or a negative value, because there's 2 different ways to find a number in here and square it and make it equal to 20. You see, we have y minus 2, whatever's inside of here, squared can be 20. So this here could be a positive or a negative value, because a negative times a negative makes positive. So y minus 2 could be a negative root 20, or it could be a positive root 20. Here, this is a positive root 20.
Yeah. So how do you get, like, because it looks like they're not, like the y, the 2 points on the y-axis, they don't look like they'll be exactly, like, one's positive, one's negative. Like, how do you get 2 answers?
Okay. So this is one of our answers. And the second answer is going to be subtract the square root of 20.
Oh, okay.
So I need some colors. So when I drew in this radius here, that radius is at x is equal to 2. So if I went, and if you look at this symmetric wise with a circle, this distance going up is a distance of the square root of 20. The distance coming down is also the square root of 20. The distance is. So we go to 2, we add root 20. We go to 2, we subtract root 20. Sidebar, because this is important stuff. It's really important stuff. We did parabolas during COVID school last year, and we solved using the quadratic. And what we did is we said, well, x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. And you go and you solve that equation when you put numbers in. So you might have an equation that would be like 2x squared plus 4x plus 3. I hope that works. Let's do this, then we'll be safe. Subtract 3. So if you went and solved that in the quadratic, there comes a point when you're solving the quadratic formula where you have some number plus or minus whatever is underneath the radicand symbol. And there's this line of symmetry in parabolas. And that number plus gets you to here. And the number minus whatever's in the square root gets you to there. So there's symmetry in that kind of a solution. There's symmetry in a circle also. Now,
So the question is,
so for number 9,
yeah, for number 9.
yeah, it says find the coordinates of all points of intersection of the circle and the line with the given equation. So the line of x is equal to 1 goes right through here. So what we have is we have this drawn here, there, and there. Those are your 2 intersections. Those are the 2 points.
So then how do we get the coordinates?
Well, you're 1 over on the x-axis, and then this is your y value. So in terms of x and y, this would be 1, comma, 2 plus the square root of 20. And 1, comma, 2 minus the square root of 20. Those are your 2 locations. And I think it says exact, doesn't it? Well, it says find the coordinates, but there they are. So then when it says y equals negative 3, so that's a horizontal line going across down here, isn't it? And you're going to end up finding 2x values in much the same way. And when y is equal to 9, that's the third part of this. Let's look at this. 2 is the y value. This thing has a radius of 6, so it only goes up to 8. So at 9, if you put a line across here, is there a point of intersection?
Nope.
So there is no solution. It can't be done. So if you put 9, is that right, 9 in here, 9 subtract 2 is equal to 7. 7 squared equals, and when you subtract 49, that becomes negative, and it's not possible to get a negative answer here. Would you like to see that real quickly?
Sure.
So in this equation here, we have x minus 5 squared plus the 9 minus 2 squared is 36. So then you would, that's 7 squared is 49. When you subtract 49, just, you gotta trust your arithmetic, or trust your math, your algebra. And you have this right here is equal to a negative 13. And if you say, well, what's the square root of that? Well, it's the square root of a negative 13. We don't know how to do that. Therefore, no solution. In a year, you'll know how to do it, but not this year.
So
There is a solution. A good dinner conversation at your house. But not here. We're not ready for that yet. Okay, so for number 11, they give us a center. Is that correct? They say the center is negative 7, 4. So they say 0.8. And then they go and they say, and it contains the point negative 10, 1. Find an equation for the circle. So this is point A, and point B is negative 10, 1. So let's just say it's up here somewhere. So we need to find an equation for that circle. And I think if we start with this idea up here and see how much of that information we know, we might be able to get started.
This one,
Yeah.
the points for A is negative 7, 4.
Oh, it is?
Yeah.
Thanks. Okay. Good.
And then 4, not negative 4.
Or not 4. There, that'll make a big difference, won't it? So then this point would really be down here somewhere, maybe. Just for drawing, making a picture of it. Okay, is that better?
Yeah.
Thanks. And this is point B. Okay. So how much of this equation can we write in with what we know? What's that? A good bit. You see, the x and the y will remain x and y every time we write an equation of a circle. Those are your two variables. What changes are h and k and r. So do you know what h is from this information? What is it? 7 or negative 7?
7.
Negative 7. H and K are the center. So you literally take that and put it in here. It is exactly the way it is. So you say x minus, and then the H value is negative 7. And then you do y subtract, and the K value is actually 4. So now you just need the radius squared. And do they tell us the radius? No, so now you have to calculate it. So how would you calculate that radius?
X1 minus X2. Wow.
What's the formula called? Not
Distance.
slope, it's distance, the distance between 2 points. So the distance along here is r. So distance formula? So the distance between 2 places, we're going to call it r, is equal to you have 2 points between the two that you're going to measure the distance between. From this point to this point, plug it in. And then you'll have it. Can you finish it? Can you finish this one? No?
I think you should do it.
You think I should do it? No. What's one of the points that is given? I think if nothing else, you could have your notebook open to where the distance formula is and take a look at how to stick things into there. Because when it comes time for a quiz on Friday, a long quiz on Friday on these 4 lessons, you can have the distance formula in there, and I'm not gonna say to you, hey, this is how you do it. So you gotta find the equation, you gotta find the exact circumference, and then you gotta find the exact area. Let's see, so 16. Oh, so number 16 is the same thing, isn't it? Find the distance between 2 points. And if that distance is equal to 3, but then you gotta figure out what the x values are, or the x and 2x values are. This is 11. Because we have a property.
Mr. Bagan, you did it wrong.
What did I do wrong?
According to Kelly, you did the square of the second parentheses.
Where?
Oh,
Oh, yeah,
Oh, this?
no. Oh, yeah,
and
but the other one
and
too.
the other one.
Oh, and this. You're right. But we haven't done anything with it yet. That doesn't make anything else that I did wrong. I don't believe. No. Okay, keep going. Find that radius. And then you take out 18. Here's the triangle. Okay, well, 18 is equal to 1 times 18 is 2 times 9, 3 times 6. So any of those factors that are perfect square, you can get out of that and leave the rest of it. So if you look at 18 as being 9 times 2, you get the square root of 9, which is square root of 9, 3 times the square root of 2, so it's 3 over 2. And that's what it should be simplified into. That's why a big communal operator is. That's the distance formula.
That's how you find the radius?
Well, that's how you find the distance between 2 points, and the distance between the center and the edge of the circle is called the radius. Yes. Yeah. So what we're doing is we're just finding that distance because they give us a point on the circle and they give us the center. And once you know what the radius is, then you can substitute that back into the original equation. Where's your homework?
Homework is somewhere around. Did you want me to find it? Yes.
Yeah, only if you want credit for it, but, and also then you can work on this with that problem and finish it up. It'd be a good place to do that. So what do you get? It doesn't seem right, because 10 minus a negative 7 subtract the negative, that's a positive. Would be negative 10 plus 7. How far is it? We're doing here. It's not 7 subtract negative 10. It's the x subtract the h. And the x value. Wait, no, I'm sorry.
Why does it matter?
Wait, you said, you did negative 7 subtract. Negative 7 subtract negative 10 is a negative 7. Isn't it?
Yeah, they're both.
It's a negative 10 subtract.
Yeah, they're both negatives. This is a negative 10 subtract negative 7. Or if you're negative 7 subtract negative 10. Yeah, that's not. Negative 9 plus whatever that other one is. It's 9 again, isn't it? Good, you can, I like that. That's better if you said over or whatever. Yeah, so if you add arithmetic, then you want to. These are all messages. So what do you get for your
Missed it 5.
Can you factor that out? Let's see, I wrote root a b is equal to root a times root b. Can you factor that thing out that way? Alright, where are your notes with the distance formula? Plus I have the distance formula written right there as well. R is equal to square root of. So you're using those 2 points and writing that in. What did you get for a radius? Okay, so can you take the 18 and factor it with this idea here? A number times a number, and then you can separate their 2 square roots. And can you use one of those as a perfect square? So like, when you have 18 here, something times something equals 18, so that you can put, and one of these is a perfect square. Because then you're simplifying your square root. So 2/3 is 9 and 9 is 18. So can you simplify this, what I have written in the bottom right hand corner there? This is the area of the circle?
Are those the polytonic group?
No, that's circumference. Is it circumference? I thought it was area.
Well, area, if you do that, if so then circumference, then from there.
Circumference, huh? Find the exact circumference, and they do something like that? One of them was exact. Okay. So this here, so you have 9 plus 9 is root 18. Can you factor that 18 to simplify it?
Oh, okay.
Look at what's on the board in the bottom right-hand corner, is that idea. If you take your root 18 and you factor it. Oh, there it is. So then, what's the final equation of the circle? Really, really close.
I don't know what other one to use.
2 times 8 is 16.
Oh, sorry.
So it should be 2 times. There you go. Now you should be able to see that one. Can you see it?
Yeah.
So then how will you rewrite it? The square root of 18 is equal to. Take the square root of 9, which equals how much? Well, what number is it? Don't read for that. Put that in mind. There you go. Times the square root. So that's the exact. Have we found where we're at?
Oh, I still can't find it, but I'm positive that it was 6 fronts, right?
Yeah, we spent too much time just looking for something. Gotta be able to dig that out faster. So, have most of us gotten to the radius? I think a lot of you have. Almost all, yes. Yes. But, sort of, but you have to put them in this form up here, Mayor. Okay. So you guys came up with a radius that would be equal to 3 root 2? Okay, which is the same as square root of 18. But I think pretty much all of you have factored it. So now what we can do is we can go up to this equation here and substitute root 18 in and square it. And then you would have a final equation written as, you want to simplify this. Try not write it as subtracting a negative, but plus 7 squared plus y minus 4 squared is equal to 18. There's the equation of your circle. And what's really cool is that you can just throw that into decimals and you can double check your work and see if you can drag and find this point on your circle and you see that as the center, then you can just double check by actually graphing it. Graphing it on a TI-84 is a little bit more challenging because everything has to be written as y equals. But it can be done. It can be done. Now, what was the second part of it? They were asking us for the exact circumference. So if the radius is root 18, or 3 root 2, what's the diameter? 2 times that. So what's 2 times 3 root 2? What would that be? 6 root 2. So if circumference is pi times diameter, this is going to be pi multiplied by 6 root 2. That's exact. And then they ask us for the exact area. The area of a circle is pi r squared. So then we take this radius right here, and we're going to take 3 root 2 and multiply it by itself. So, if you were to rewrite this, that's the same as 3 times the square root of 2 times 3 times the square root of 2. 3 times 3, root 2 times root 2, 2. So that's just 18 pi. If you would have gone to a calculator and then started writing things down as far as your decimal numbers, and then try to square them, you'd never get back to a nice clean number like this. At this stage here, you would be able to get rid of, if you're looking for an actual number for an estimate, you could use pi, you could get the square root of 2 in a graphing calculator, or in a calculator, but otherwise, just leave it like that. So how do you get a picture of that on your graphing calculator? I don't have time for 16 right now. And I will do it. But, gosh, I need a lot of room, sort of. To graph the equation of a circle, it looks like this. You've got x and you have y, and then you need to know what your radius is. Yeah, you're right, yeah. This is just complicated. You gotta take the equation, you have to run it through inverse operations, and then you get two solutions, and one has to be a positive and the other is a negative, and it's ugly. Yeah, just put it in decimals, because you can have it in any form of decimals. You can put it like this is right here in decimals, except you can get rid of the r squared, and you can put 18 into there. So if you you put just like this with an 18 in that place, and decimals will give you a perfectly round circle. It'll give you the whole equation. Whereas your graphing calculators only graph functions. So if it doesn't pass the vertical line test, it won't graph it. Okay. I guess, knowing that, if you had a question on 16, my guess is many of you would. After what we did here, look back at number 16 between now and Wednesday. And then we'll go further from there on Wednesday. Are any of you out on Thursday for vaccination? Yeah, that's the, is it? Yeah, what, Thursday the 8th for vaccinations. Any of you out for that? Are you getting vaccinated?
Yeah, mine's in the morning.
Yours are in the morning, okay. Music, I've got a list of you, so. All right. Yeah, don't forget, you want to retake, this is it, this week.
Bye now.
Goodbye now.
Wait, Carol, are you getting vaccinated?
I don't know.